Hi, I'm Pete, and I'm doing this new web series, Instrumentation in the Field. Today we're going to take a little field trip to a local store that specializes in industrial surplus.
Today we're in one of my favorite places in the world, Axeman Surplus in St. Paul, Minnesota. One of the things I want to show you is this. Looks like a brake cable lever and handle for a bike, right? Well, it mostly is, except for one thing. This isn't a brake cable. Now instead what we have here is an electrical cable of some sort, coupled back to what seems to be a variable resistor inside of the handle. Now if we pull this open, see down in there, there's a little spring mechanism, something like a gear mechanism that's actually pulling on a variable resistor. And the reason why I know it's a variable resistor, even though it's got only 2 pins here, is because of the fact that that's about the only way that you can control this. So what happens here is that you're basically pulling a wiper across a piece of graphite or some sort of other resistive material, and you wind up increasing or decreasing the resistance between these 2 pins right here. So as that changes over here, this resistance changes, you put that in series with another resistor between ground and power, and you've got a voltage divider that gives you a signal out. If both sides are 0 and 5 volts, for example, then you've got a voltage controller that can run most motor controllers. Now that's a lot of power resistors. Speaking of power resistors, now this is an interesting setup right here. This is for high power but also high precision. So if you take a look at these ohmite power resistors, you may notice that there's some amount of enamel missing on the outside, and you'll see there are these wipers. So what this allows you to do is, in some sort of series parallel array, adjust a bunch of power resistors to exactly the resistance that you want, and then fix those in place when you tie them down tight with these little screws on the side. So this is a way of getting exactly the resistance you want, but for a couple of hundred to a couple of kilowatts. Normally when you think about relays, you think, oh, that's a relay. Well, that's a relay. If you take a look at this, we've got a square D magnetic relay here, rated for 600 volts, 5 kiloamps. The reason why the rating's so high is because you're triggering a link between these 2 circuits right here. These 2 circuits right here across the top. If you take a look at this right here, this is actually for the coil, which needs to be pretty darn beefy and pull a lot of current, since the magnetic field is proportional to the, since B is proportional to I, magnetic field's proportional to the current moving through. So this is actually a low voltage, high current application for the coil. And then for the contactors up here, these things essentially go to bus bars or really, really honking huge pieces of cable. So that's a relay. This is true. This is why we can't have nice things. So I'm shooting this on a Sony Handycam, and here's its very, very distant cousin, the Sony motor. Now, in front of this, if you've been around in IT for a couple of decades, you may notice this as a front piece which would hold a tape cassette. You'll see also right here that there's a solenoid which is basically going to run a braking mechanism so that you can get very precise starts and stops. On the back of this, you have a large, what seems to me to probably be a stepper motor. No, actually, Given the two smaller wires on here, I'm going to go ahead and guess that those are some sort of sense wires, and then these are actually power, in which case this is probably just a DC, either brushed or brushless motor. But on the back part here, and this is the part that all of these wires come out of, you have this rotary encoder, which seems to me to be magnetically encoding. So there's that little brown strip around the outside of this back wheel, and that's actually going to give you a magnetic signal through these little sensors on the side. They either might be Hall effect or some sort of small reed switch. But yeah, this provides very precise positioning feedback for the motor so that you can get to just the part of the tape that you want. And call it art. Now these right here, these are cool. This is a linear actuator, and you're probably not going to find them for cheaper than the 40 bucks that they got them for here anywhere. These are designed to give you about maybe 6 inches of throw on the front side by basically having a rack and pinion system on the front of this German Oken EP motor. On this side right here, you can see there's a 5-pin DIN connector, and there's also these 2 pins right here. I've had one of these apart before, and those two are connected in parallel with each other. Interesting thing is that you can run the whole thing off an H-bridge because it's reversible, and it doesn't over travel because deep inside the belly of this beast there are 2 limit switches that actually will switch the motor off or on respectively when it reaches its limit of travel. So yeah, these I believe are originally designed for reclining chairs.
Back where the chapel is in Minneapolis, you name the happy day and I'll be there.
Now here's a little bit of weirdness I never did think I'd ever see. This is a pedestrian swing door operator by Norton/Assa Abloy, and the on-off or reset-off switch is actually contained here within the body of the device itself. I'm guessing you're supposed to take some sort of access plate off to get at that. But that's not the interesting part. There's also this power control board here with, I'm guessing that's probably an H-bridge configuration of FETs here to either that or, no, it wouldn't be triax because this is an induction motor. It could be triax. Either way, that's not the interesting part. The interesting part is how you get feedback out of this thing. Right here is a magnetic switch or Hall effect sensor, and this is the part that's weird. These neodymium magnets that they put on the shaft here to encode where the door is supposed to be and where the motor is supposed to be are loose. These are not actually held in place, which means that technically you can spoof this thing if you move the magnets around. I've never seen a feedback system quite like that. And the rest of this is really well designed and engineered. Maybe those are supposed to be held in place with Loctite, because this whole thing even has a level built in, a little vial spirit level back there. In the back, there's a tiny little power supply here. Looks like 24 volts DC at 1.1 amp. Ooh, I might want one of those sometime. But yeah, strange. Or to quote AVE, "Whoa, that's weird, man."